How about shifting from reactive to proactive? So AIOps, as we know by now, evolved from a combination of conditions such as maturity of machine learning and AIOps, and these technologies becoming available, massive increases in the amount of data volumes being produced and the ever-growing complexity of systems. So, we've said that before. Adopting AIOps to solve these issues imposes the need for various shifts in how a team approaches system operations. So first of all, you need to understand the past and how that relates to predicting the future. So the implementation of AIOps systems require a set of fundamental changes to the mindset of IT operations and team leaders. The core shift is from tools that focus on analyzing past events and calculating absolute numbers that represent past behaviors of a system to a tool set that aims at proactively supporting the operation of a system by discovering new patterns and causal relationships. These are some characteristics of a reactive approach to operations, the traditional approach. Some of the common characteristics. The first one is events and alerts, requires events and alerts prior to any action being taken. And it also involves lagging indicators, relying exclusively on indicators, so how things happened up to the point of monitoring, for example. And monitoring, focusing on monitoring instead of observability. So the idea of having prescribed things that you're looking at. And finally, isolation, number 4, works with system components in isolation from each other rather than as a complicated topology or distributed system. So traditional operation approaches are reactive. They don't sufficiently support the ultra scale and complexity of modern systems, which are composed of hyperscale distributed cloud native architectures. Okay, so a proactive approach to system operations is different. Adopting AIOps allows teams to evolve proactive patterns of system operations. So some of the characteristics here are using past data in correlation to identify patterns and provide early warning for issues before they happen. Focus on leading indicators instead of lagging indicators. Discover and map dependencies across systems before incidents arise, and actively and continuously reduce noise by continuously identifying a functional baseline, as well as thresholds for anomaly detection, anything that is abnormal, predicting abnormal behavior trends. Arguably, the only through proactive operations can teams manage systems at cloud hyperscale while satisfying ever more stringent expectations to system performance and resiliency. Okay, here's the first activity in this module. We recommend you spend about 15 minutes on self-reflection. The question here is, are your teams currently reactive or proactive? So, based on what you have just learned about reactive and proactive approaches, maybe what you could do is create a piece of paper, 2 columns, label one reactive, one proactive, list the ways in which your team or organization behaves. Where you're reactive, consider solutions that you could implement to evolve to be more proactive. So it's a little exercise. So I'd stop the video and give it some thought. Assuming you did that, I'm moving on. Here's a case story for this module. We're getting to Papa John's, pizza business. With Splunk's observability and AIOps capabilities, we have information at our fingertips, so we can react and innovate faster on behalf of our restaurants. We're in the moment business. When customers order, they need speed at the moment. We're constantly releasing new features, but resiliency is at the center of it all, so our systems are always available to our customers in restaurants. The result of that is they accomplish faster innovation, faster reactions, improved customer experience, and improved resilience. Attacks have been changing dynamically, and Splunk has helped us quickly react to tune our preventative control. So I guess they're talking about security improvements as well. Okay, let's talk about deterministic to probabilistic approaches. Certain past, uncertain future is the title, but basically it's the idea of considering what is deterministic and what is probabilistic. So implementing AIOps solutions with capabilities of AI, machine learning, and generative AI can help understand data, predict outcomes, and generate response actions, providing IT with radically different ways of viewing events and actions. So deterministic includes things like analytics and traditional operations, whereas probabilistic is more about using machine learning, prediction methods, and generative AI to automate analysis and actions. So deterministic, you're dealing with consistent inputs and consistent outputs. That's almost the definition of what deterministic means. With the same input, you should get the same output. These systems are always consistent in their output, considering identical inputs. In other words, the result will always be the same for all executions given identical inputs. So in traditional system operations, alerts are triggered deterministically. Having a defined specific threshold for a given set of metrics, an alert will be triggered when that threshold is breached. Probabilistic systems, on the other hand, in a probabilistic system, the output is not certain. The system represents one of multiple outputs given various possible identified patterns in historical data. The extent of uncertainty will depend on multiple factors, including the algorithm and data used in its training. Incorporating the concepts of uncertainty and randomness as applied to AI are key to ensuring that the most value can be extracted from the AIOps solution, and that the possible downsides of applying AI to IT can be averted. So here we're talking about different aspects of probabilistic randomness and machine learning, and Gen AI can be introduced at various stages, both from the data itself as well as into the algorithm to avoid overfitting. The undesired behavior in an AI model provides accurate predictions with known data, but it's inaccurate when you have new data sets. It's important to understand the caveats of going from a deterministic point of view to a probabilistic one in order to get the most desired results. Poor data will introduce a much higher degree of randomness and uncertainty, likely resulting in poor performance, false positives, and otherwise negative and risky behaviors. So predictions, classifications, and other outputs provided by an AIOps solution should be carefully evaluated over time, ensuring checks and balances exist to understand and optimize the machine learning model performance.